Hi, welcome Abhishek. So in this mock interview round, we'll be taking up edge deployment interview questions for computer vision architect or a GenAI architect at an organization like Cyient. And the objective of this discussion is you have to explain us how you design, optimize, validate, troubleshoot, and communicate production grade edge AI deployments for computer vision and medical imaging systems, including model optimization, ONNX Runtime, regulatory considerations, MLOps, and trade-off decisions. So before we get started, I would like to give a quick summary of what Cyient does and what their latest annual report says. So their latest annual report says they are moving on to the next orbit. Okay, they are trying to position themselves as a global intelligence engineering company, and currently they are serving around 300 plus customers across 30 plus countries, and they have 15,000 plus associates. Okay, they have certain verticals in which they serve aerospace industry, rail, automotive and mobility, connectivity, utilities, mining, energy, healthcare and life sciences, and spatial intelligence. So our today's context is around medical imaging and healthcare. Just wanted to give a quick understanding of the vertical they have. So they have a digital engineering and technology vertical where this is the major segment they have in which they do this maximum revenue, and I think they have made over 5,000 crores of revenue this year under this DET business. I think they're also looking up to design-led manufacturing and semiconductors, and around I think their majority market is in North America, which is around 50% plus, and in Asia Pacific, they do a business of around 21% out of the overall numbers which they do. So that is what is the status which they have. Okay. Now, if you see, they have done good revenues in numbers. So consolidated revenue from their operations is around 7,268 crores. They did a profit of 427.9 CR. Their standalone revenue is around 2.363 CR. And these are their EPS and standalone, earning per share, which is consolidated EPS is 38 rupees and standalone EPS is 14. So the company is doing good. So tentatively, Cyient is a 5,819 crore company. Their growth is around 5.5%. They are positioning themselves as a global intelligence engineering leader. They are trying to get to the next orbit, which means they are currently at X status and they also want to move to Y status. And they are looking for workforce, manpower, those who can take them to the next orbit. Okay. So if a candidate places himself that I would be the one who can join the mission and take this organization to the next orbit with my previous experience with healthcare, life sciences, edge deployment, and all of that, which you're planning to do in the upcoming, years, that sets a different value proposition. Okay. So this awareness among a candidate defines a high value candidate for an organization, okay, which an organization would fight for. Then they have done an EBITDA of around 712 crores. Net profit is around 588 crores. So it is a profit generating organization. Around 731 CR is the free cash flow they have, and their free cash flow to normalized PAT conversion, profit after tax conversion, is around 124.3%, which is good. Okay. Now, so this is a quick overview of what numbers they are doing, what kind of segment they are into, and how they are using edge deployment. So what they are doing in edge deployment part, let's have a quick understanding. So Cyient's edge deployment story is mainly represented through their product CyMedge, CY Medge. Okay. And what they do here, so it is an accelerator described in the annual report as an edge enabled platform that offloads compute and storage intensive workloads to optimize performance across distributed infrastructure. So they are enabling edge enabled platforms that offload computes and storage from cloud servers. And in fact, they are doing this edge processing on the device itself, on these medical devices itself. So that is what they are currently doing, and where they are deploying these edge deployments under medical imaging and healthcare devices, where process scans for device data locally, where process scan for scans the device data locally for faster regulated workflows. Then there are industrial cameras which detect defects, safety events, human poses, or objects near the production line itself. It does not need to go to the server and come back. Then they are using this in telecom networks also, where they monitor and optimize distributed network infrastructure. They have certain field assets as well, where they process sensor data near remote machines or infrastructure. They're using edge deployment in manufacturing also, where they run quality checks close to production equipment. And they're doing predictive maintenance as well, where they detect abnormal equipment behavior before failure. Okay. So these are certain use cases where edge deployment could be of a good use. And they typically have a product for that as well, which is Cyient. Now, so this is what we are going to discuss. So, in short, if we have to have a quick understanding, which means Cyient is using edge-enabled AI to move compute-heavy and storage-heavy workloads closer to cameras, scanners, machines, network nodes, and field assets. That is what they're doing. They are offloading it from the server side to the edge devices themselves. Okay. The goal is faster response, lower bandwidth cost, better reliability, improved privacy, and practical AI deployment. So now let's get to a quick case study, which I have shared with you. So how Cyient uses this? So they process data near the source and send only useful insights to enterprise systems, and they improve speed, cost, and reliability. Okay. They have this product, Cyient, which is an edge-enabled platform that offloads compute and storage-intensive workloads to optimize performance across distributed infrastructure. We are well aware about it now. I think you have already understood this, how Cyient is doing. Edge deployment helps them in faster decisions, lower bandwidth load, better reliability, and lower operating cost. And they are deploying edge deployments at video intelligence, predictive maintenance, telecom and network operations, manufacturing intelligence, healthcare devices, field and asset monitoring. So this is the overall area where they are deploying it. Okay. And these are certain practical architecture flows. Data is generated through cameras, sensors, embedded systems, machines, telecom equipments, and field devices, which creates raw data. Then there is a local edge processing. So Cyient, what it does this edge capability. They run their heavy compute and storage workloads near the source itself, near the cameras, near the sensors. Okay. Then AI extracts those signals, computer vision, anomaly detection, OCR, predictive modeling. All these patterns are identified. Then the insights move upstream. So alerts, summaries, scores, compressed outputs, these go to cloud dashboards or enterprises. So instead of everything going to cloud, everything is done at that edge near to the source. And then from there, it is transmitted to the server, to the cloud. Only insights are transmitted, and that makes it more faster. Okay. Now, the data size gets reduced. All the quick processing is happening at the edge itself. Only the insights extracted is being sent to the server so that the communication can be faster. The messages are short. So that is how it is used. So the teams can act faster. So this is an overall understanding of what they are doing. So now we are going to get into the question and answers, and we'll be taking questions from Q7 to Q12. Okay. So now let's get into this. We're going to get started with the first question. So describe a practical strategy for deploying a 3D model such as 3D unit on constrained edge hardware.
Okay. My voice is clear, sir, right? So while deploying a 3D unit on constrained edge hardware, I think the primary challenge is memory consumption. Memory consumption is the primary challenge because sometimes we have like large medical volumes and they are significantly larger than the standard 2D images. So that's why I think uh, medical volumes, memory consumption, I think is one of the important points. For example, if I take a CT scan of sites 512, 512, and 300 pixel, may not fit into a available GPU memory. So instead of processing the entire volume, I would use path-based inference with patches such as 128, 12864. And also would like to overlap the sliding window inference to avoid the uh, boundary artifacts. So then, like predictions from overlapping regions would be blended using this yeah, weighted averaging. So this will help us in reducing the memory usage overall, and like we can also try enabling FP16 or 98 inference wherever supported in the system. If required, I would also redesign the model by reducing channels, pruning layers, yeah. and uh, and also I think the processing while doing processing we can have normalization and the resampling and ROI extraction. For edge deployment, batch size is typically one because latency matters more than throughput. So yeah. Finally, yeah, I would perform hardware profiling and ONNX runtime, NVIDIA or vendor tools to optimize the latency, memory, and throughput.
Okay. Okay. Sure. Now let's get to the next question. Uh, okay. Can you address memory constraints with patch-based inference, tiling and sliding windows in a little more details? And can you also touch these points again on reduced precision and model redesign?
So can you repeat the question?
So the question is, can you address memory constraints with patch-based
Mhm,
inference, tiling, and
mhm.
sliding windows in a little more details? And can you also touch these points again on reduced precision and model redesign?
Okay. Um, so this uh, when it comes to like patch-based inference, so instead of feeding the entire 3D volume into the model, we divide it into the smaller sub-volumes of patches. For example, if we have original CT scan of size 512, 512, 512, and then processing patches may include like 6464 or 128, 128, 128. So the workflow is like splitting the volume into its patches and then run inference on each patch and then merge predictions to reconstruct the entire segmentation mask. So by doing this, we can dramatically reduce the memory consumption, and it also allows the deployment on limited constraints, memory space.
Okay.
Sliding window inference is one. This is usually preferred over simple tiling. And instead of non-overlapping tiles, like windows overlap with each other. So you run inference on overlapping windows, average predictions in uh, overlapping regions, and then you stitch the outputs together. So this also reduces the edge artifacts and like we can reduce the constraints. Make it run.
Okay.
Yeah.
Okay. Let's get to the next question. So the next question is, how would you design an ML ops and CI/CD process for edge AI models so that updates are safe, reproducible, and easy to roll back?
Yeah. Safe, uh, reproducible, and easy to roll back. Yeah. So my preferred way would be like everything should be version. So whether it's the data or code or the artifacts, uh, configuration and runtime, and will include tools like Git, DBC, MLflow, Docker, model registries that will help us in maintaining the versioning and traceability. So the CI pipeline should be include unit test, pre-processing validations, uh, model export tests like ONNX or Tensor RT, inferencing regression test, and including latency benchmarks and some security checks. So the deployment gates should also like we have to ensure that accuracy, latency, and thresholds are met before promotion. And I would use a stage deployment with development, QA, and like production environment, the three phase. Uh, it's a new in case if we are building new models, so that they would first be deployed to a small subset of devices before like the broader global rollout. And this way we can enable the monitoring uh, and track the like latency, resource usage, computations, drift, model health, and system errors. And yeah, the rollback should be one click and based on immutable model versions. So maybe audit trails should record who deployed what, when, and why. So this approach will ensure model recycle cycle management while managing the operational risk.
Okay, let's get to the next question. Tell me about a time you had to balance accuracy with latency or memory on edge.
Yeah. So in my one of the previous projects, we needed it to deploy a computer vision model on resource constrained hardware where latency requirements were strict. So my responsibility was to maintain acceptable accuracy while ensuring inference completed within the stipulated time. What I did is I analyzed the bottlenecks and evaluated the multiple optimization strategies, including optimization or the simplification of the architecture. I also tried input resizing and pipeline optimization. And I also collaborated with the stakeholders, platform engineers, and the product stakeholders to define the acceptable thresholds. So yeah, I mean, by doing by doing this, we achieved the required latency target while maintaining within an acceptable range. The solution was accepted. So I mean, because of the project details are confidential, so I focus on the decision process and measurable trade-offs.
Okay. Okay, let's get to the next question. Okay.
So the more,
Yeah. So let's see. What are the most common failure points when integrating an edge AI model into a production imaging pipeline, and how do you prevent them?
so based on my experience, some of the like failure points include pre-processing mismatch between like training and deployment, and sometimes the orientation of the image is also not good, incorrect spacing or scaling is there. Then the DICOM metadata handling errors. That's also common issue. Uh, Sometimes when we uh, export like that we might face the unsupported operators during the export model export. And what else? Sometimes like we don't have visibility everywhere, so lack of observability and monitoring to the all the components. So yeah, I mean to prevent this issues, I established uh, like interface contract, maintain golden test data sets so that we validate DICOM metadata handling also and then automate the integration testing and also like inbuilt, like a pre-built deployment checklist. So this would allow us to handle failures easily.
Okay. Okay. Let's get to the next question. So the next question is, how would you explain edge deployment trade-offs to a cross-functional audience such as product managers, clinicians, QA teams, and DevOps teams?
Tough one. Uh, I mean, different different stakeholders care about their different outcomes. Maybe one thing is important for one, another one is not important for the another one. So, for example, for clinicians, focus on patient safety, reliability, workflow, consistency is the one. For product managers, like they focus on value, business value, deployment timelines, cost, scalability thing. And for QA teams, like they focus on validation coverages, uh, uh, risk mitigation, and testability. And for so we have clinical and DevOps teams. So DevOps, I think they focus on the more automation part, deployment automation, and the rollback mechanism and operational stability. So uh, yeah, I mean these are the thing points that I would consider.
Okay. Okay. Let's take the last question, and you have 2 minutes to answer this. If you joined Cyient and were asked to review an existing edge deployment for a vision model in the first 30 days, what would your assessment framework would look like?
Okay. Can I just take a couple of seconds to structure my thoughts?
Yeah, yeah.
So frameworks. The broader points that I would I would consider during the like first 30 days. Uh, that would be like first is like model quality, like uh, accuracy, robustness, drift, drift is happening or not. Validation methodologies, what they accept considered, and then deployment architecture is also where I would focus more because like how the inference pipeline look like, uh, what is the fault tolerance mechanism, and scalability, how they have scaled it, and what methodology they followed while doing this. And also the hardware like what is the memory utilization, throughput, power consumption, and optimization opportunities to identify like wherever it is possible. And some tests like testing strategies, what they are following. Is there any scope for doing some like improvement there? Regression testing and acceptance criteria, what is their benchmarks, and how the system is behaving. And then MLOps maturity, like how versioning, CI/CD, rollback, documentation, compliance requirements look like. Are they in place or not, updated or not frequently, versionings are maintained or not. And yeah, I mean, there's one more thing like if regulatory and compliance readiness checks are done or not, so traceability and audit auditability things from that perspective, things are organized or not, and some domain specific requirements, the
Okay.
documentation is done or not.
Mhm. Okay. Okay.